All right, today we look at chapter 6, multiple integral. So under this chapter, we'll look at double integral, triple integral, and some application on that. All right. So what is double integral? Double integral is, you will see two integral in the equation, right? So you have this form, integral function or equation in the middle, and then dx dy. So this is called double integral. Right, before this, we have solved a lot of questions about single integral, right? So the procedure, when we see this kind of question, what we do is that we solve the middle part first. We solve the middle part. We solve the middle part means we solve the center first. We solve the integral of inside. For example, if you see dx, you do the dx first, then you expand outside. Okay, that is the steps to solve double integral. Okay, so this basically what I explained just now. You start with inside, you do the inside procedure first, then you substitute back into inside center here to do the outside integral. Right? So just need to be careful on the limit here. Inside limit is referring to this one. For example, this one refer to x value. Outside is refer to the outside value. You have one more. If you later you see the triple integral you refer to the third number. Okay. Which kind of question you will see double integral? Normally, you will use it to find the area under curve, or second moment of area when you do introduction to machine or about machine, gear, shaft, and all this, to find the centroid, moment of inertia I, and so on. So sometimes this format, integral function dx dy, you can write as, you can pull your dy to the front. Okay, you can pull your dy, this one, to the front because this one, the first integration that you see is dy. So you can pull the dy to the front and see it as two integral process. First, you integrate dy, multiply by integrate of your dx. Right? It makes sense, right? So you can break the double integration into two integral process. Right? You can break this example. You integral dx dy, double integral into integral dy multiplied by integral of your dx. You can break into this process. Okay, today we recap and recall some of your integration skill. See if you're still able to remember how to do integration. Now we look at example 1. You see two integral sign there, means this fall under double integral section. And this one you integrate dx and dy. So what is the first step? You always start from the center and then expand outside. So you focus on the center first. At the center, you're seeing integrate from 2 to 5, and then the function 2x minus 3y dx. Okay, Shakir, are you there?
Yes, sir.
Okay, Shakir, can you solve this integral, this integration? What do you get? What is the next steps? 2x become what?
Or 2x to the power 2x square over 2.
X
Which is
squared
x
over
square.
2 become x squared, correct.
And
Then this one, minus 3y become what?
minus 3 over 2 y square.
You are integrate with what? You integrate with dx, huh? So what happened to your 3y?
0, 0, 0.
Huh? You are doing
0, 0.
integration now, not differentiate. Integrate
Eh,
always
oh.
add, right? Integrate always add 1. So become, you integrate 3y over integrate 3y with dx. What do we get?
1 is it?
No, if you integrate something that different, what do you see? This one you see as a constant value, then what do you get?
0.
You integrate 1, you get 0. You integrate
Oh,
1
x.
dx.
Sorry.
So what you get? Minus 3y integrate over dx, what do you get?
Get x.
Multiply by the constant, what do you get? You see this one as constant. Minus 3y as 1. So you just substitute back the 1 become 3y. What do you get?
This is my girlfriend.
Wait. Can you repeat that, sir?
What do you get if you integrate minus 3y dx? You integrate 1 dx, you know you get x, right? So you assume, not assume lah, but you see 3y as one whole number. So okay, you integrate 3 dx. What do you get?
3.
You integrate 3 dx. What do you get?
3x.
3x. You integrate 5 dx. What do you get?
5x.
5x. Now you see 3y as a constant number. Then what do you get? Integrate 3y dx. You add 3y, right? I mean, how you get 5x just now? You maintain the 5, right? How do you get 5x when you integrate 5? 5 over dx. How do you get 5x? So you get minus 3yx. You get this one. Okay. Then you remember on the limit, this is also the careless mistakes done by student. So follow the limit. It's not always start from 0. So there's a value there. Then you simplify, you get this one. Okay. Then you substitute the value. Okay, you substitute the value. So you substitute 5 to the first set. So 5 square minus 3y times y, get the first set, minus bracket, substitute 2 into the second, the equation. So 2 square minus 3y. You complete this one. So in exam, please give me these steps. Don't straight away jump to the answer. You need to show the substitution steps in your test or even in your quiz later on. Okay, so when you substitute, you arrive at this equation. You simplify, you get 21 minus 9y. So you solve for the middle integration already. Then you import back. This is the original question. You already solved the middle already. You already solved integration something dx. You already solved this one on the left hand side of the screen. So what do? You substitute this answer. You substitute 1 minus 3y inside here. You replace the whole thing with 21 minus 3y. Then you continue do your integration. Okay. Now it's no longer x. Now you do dy because you already solved the middle. So this whole thing you already replace from integration to dx, already replaced with this one. So you only left up with the outside one. Integration something dy. Okay, Nizam, can you try to solve this one? What is the next steps? 21 integrate by dy. What do you get, Nizam?
21y.
Okay, then this one?
One y power of 9.
You integrate y, what do you
Negative
get?
y power.
No, you integrate y, what do you get? Okay, you integrate x over the x, what do you get? You integrate x
One.
dx. No, you don't do differentiation. We are now doing integration. Integration means you always add one, right? You always
Yeah.
have something. So
X power of 2.
so if you integrate x dx, you get x power 2 divided by 2, right? Now this one, you integrate y
Yeah.
dy. What do you get?
Y
Y.
y power of 9 over 9.
How become power of 9? You maintain the constant value.
Yeah.
You do something about the y. What do? You integrate over dy. Just now you can do the x. You just replace the x with y. You integrate y dy. What do you get?
Y square over
Y square over
2.
2. Okay. So this is what you get. So this one you integrate again. You integrate, you get 21y, and you integrate this one. Copy the constant. You focus on y. So y power 1. So when you integrate, plus 1 become 2. Carry the 2 to the denominator. Okay. Then be careful on the limit. In this one is 1 to 3. So 1 to 3. Then you do the next step is that you do the 2 bracket. You have 2 big bracket. First bracket minus the second bracket. So you substitute the 3 in the first bracket, 1 in the second bracket. So you do the substitution. So 21y, 21 minus 21 multiply 3 minus 9, 3 power 2 divided by 2. First set answer. Minus, you substitute 1 inside there, 21 multiply by 1 minus 9, 1 power 2 divided by 2. You get the second set. Again, your homework. I believe you can do the same on the right hand side. The answer is 6. So this is how you solve the double differentiation equation. Okay. Right. So this chapter is more on your integration skill. You only need to remember how to do individual integration. Then you do step by steps, and then you substitute back to the position. Okay. Let's do another example. Any question on the first example? Any question before we move to example 2? Edmund, you okay?
Yes, sir.
All right. Nizam, you okay? Yeah. Shakir, you okay? Yeah.
Yeah, okay.
Okay, sir.
All right. Good. Let's move to the second one. Let's see if we can solve this one. So you're given double integral question. So the first integral from 0 to 4, second integral from 1 to 2, and then you give your function, and you are giving dx dy. So remember, the dx one is for the center one, then dy is for the outside one. Okay. So you solve one by one. You start from the center. Okay. You pull the center equation out, and then you solve it first. So you integrate 1 to 2, and then the equation 3x power 2 minus 2 dx. Then you try to solve this one. Okay, Edmund, what do you get after you integrate 3x power 2? What do you get?
3s power 3 over 3.
Correct. Then what happened to minus 2?
Minus 2s.
Correct. Okay. So you do the simple integration. 3x power 2 become 3x power 3 divided by 3. Minus 2 become minus 2x if you do integration. Then you integrate from 1 to 2. You substitute. Again, you do 2 set of calculation. Okay. You do 2 set of calculation, or you can simplify first. And then you substitute the value. So you have the first bracket. You have the first bracket, second bracket. First bracket, you substitute with 2. Second bracket, you substitute with 1. Okay. Then you slowly calculate the value. The value is 5. Okay. So the first set, the middle set, you get 5. So it just asks you to continue the calculation. This is the question, right? Given by the question. You already find the middle one. You already find integration of 1 to 2 equation dx. You already find this one on the left hand side. So what you do, you substitute the final answer of the left hand side, which is 5, inside here. From here to here, you substitute as 5. Then you do like a normal integration. You replace this one to this one with the previous one. In this case, it's 5. So you integrate 0 to 4 dy. Okay, Shakil, what is the next steps? It become what? 5 become what? When you integrate over dy, Shakil?
5x.
What? 5x, how you get x?
A5y.
So be careful. This is a careless mistake. You need to be
Yeah.
careful. You need to look carefully what is your dx or dy. So second set is already dy already, so don't do x. Okay. The first set, yes, dx,
Yeah.
but the second set is dy. So you get 5y, 4 to 0. So of course, you know the first bracket you multiply by 4, second bracket you multiply by 0, you get 0. So the answer is 20. So this is the answer for example number 2. Easy, right? So again, the careless mistake is the second set or the third set. If you do triple integral later on. Okay. So this, some student, you will make mistake here. You will continue to integrate over dx. So again, this one is follow the outside one, not inside anymore. Inside you already solved already. Okay, let's try maybe another one. Evaluate this double integral equation. Integration of 1 to 3, 0 to 2, and then give you one equation. Dx dy. So again, you start from the center, then expand outside. You start from the middle. So the middle one is integration of 0 to 2x squared y dx. Okay. Now again, this one is a one simple equation combined together. You can see as one equation. You have x and y multiplied together, so it become one number. Okay, now you do the x. Nizam, can you try to solve? What is the next steps when you integrate this equation? When you integrate 2x squared y over x.
2x power of 3 over 3y.
So when you integrate the x, you focus on x. Other thing you see as a normal, and then you just throw outside the equation. Then you combine together. All right. So if you dx, just focus on the x. So you just see the x and then integrate x. So this one, you get this one. And then after that, just substitute the value 2 to 0. Okay. Substitute the value, you get 16 over 3y. Okay. I think I miss out the y here. I miss out my y in the PowerPoint slides here, right? Just when you do revision, just be careful. Right, my y is missing in my PowerPoint slides. Okay, then the answer you get 16 over 3y. The next step is that you copy the question one more time. The question you copy, and then you know that you already done this one to here. You already done the inside integration 0 to 2 something dx, which is on the left hand side. You already do already. So what you do, you substitute this one inside the middle. You get this equation. Integration of 1, 3 dy. This one you already solved dx already. Now it comes to dy, and then you copy what you solved just now. Okay, now you integrate dy. Shakil, what is the next steps? If you integrate dy. Shakil, what is it? 16 over 3, then y become what?
Y square.
Y squared, then?
16 over 3 over 2.
Okay, so 16 over
30 32 over 3
How you get
y
the,
square.
sorry, okay, how
No,
do you get 32? Hold on, okay, you integrate this one, you pull 16 over 3 outside first, right? You don't care about 16 over 3, you pull outside first. So basically you are solving
Mhm.
y problem, y dy. So what do you get? Y square over
Y square over 2.
what? Over 2. Then you continue to solve.
Mhm.
You get 16 over,
Oh, okay, okay.
you 2 is divide. Divide. So 3 multiplied by 2, you get 6. Okay. So again, Shakil, you need to polish up. I know you understand what, it's just that you somehow forget how to do integration. Okay. Yeah. So you get this one, then substitute the value inside the equation. First part, integrate, first part, substitute with 3 minus the second part, substitute with 1. Okay. Again, your homework, you substitute, the answer will be 21.33. Okay, 21.33. Or I think you can guess lah, it's 21, if you put in the fraction, 21 1 over 3. But you can put in decimal, you can put in decimal, no problem. In the exam or test or quiz, give me minimum 2 decimal place, maximum 3 decimal place. Minimum 2 decimal place, maximum 3 decimal place. Okay, let's do one more. So example 4, I pull the dy in front. Solve this kind of question. Integrate 1 to 3 dy and integrate 0 to 2, 2x squared y dx. So how do you proceed with this one? You proceed like a normal product multiplications question. Meaning you do the first part, integrate 1 over 3 dy, you do the first part, multiply by the behind one. Okay? So you can do the front one or the behind one. So you solve for the first one. This one you already solved just now actually. So you integrate 0 to 2, 2x squared y dx. Again, you are doing dx. So just focus on x. Okay. You'll get 2x power 3 y divided by 3, 2 to 0. Then you substitute 2 to the first set, substitute 0 to the second set, 2 minus 0, right? You get this one. Apologize for this one. There's a typo error on my slides also. This one should not be 1, it should be 0. Okay, it should be 0. Typo error in my slides. And actually there's no more, no more value over here. Okay, just erase this one in your answer. So again, this one will become this one because you already substitute the value, so no more value at the side. Okay, then you arrive at this one, 16 over 3y. Again, I miss my y here. There's a y here, so a loss of error in my typo. Okay, so again, if this one happened in the test, I will put a question mark and I'll give you wrong because y missing and the number appeared here. So this is a very bad example. This is a very bad example. This is not a good answer. Right? This is not a good answer. Y missing and there's number outside the bracket here because you already substitute the number here. So no more number outside. Again, this is a very bad example. And after that, you know that your question have 2 parts. You already do this part. So you can do the first part, right? Integration of 3y. Okay, integration of 3y multiply by the back one. The back one you already find is 16 over 3y. So what you do, you pull this one inside there. Okay, you pull this one inside there to do integration. So you continue to do the normal one like just now. So y integrate over dy, you get y squared over 2, right? Y squared over 2, so you get 16 over 6 y squared. you substitute the value 3 and 1. You do the homework. Basically, you still get the same answer, 21.33, which is same as example number 3. Okay, so what do you learn from example 3 and 4? This is example 3, the question format. This is example 4, different format, but both of them get the same answer. So basically, you can move around your dx and dy to form a new equation. Okay, just to show you lah. Example 3 and 4 actually they are the same. They have the same answer, and I only move the example 3. Your dy is over here. Example 4, your dy move to the front to solve the first front equation. So it depends on how you handle the question. Right, some question you need to cleverly to move the dy in front just to simplify your calculation. Right. Let's look at example number 5. Now this one will be a bit challenging for some of us, because every time you see a trigonometry, you burning already. Means you see trigonometry, sine, cos, tangent, you already like, oh, I want to give up already. All right, but anyway, still remind you, for the previous chapter, I already give you the standard table already. In the integration, for both integration and differentiation, I give you one standard table that you do conversion. Right, you get x, how you convert, right? Dy dx, what do you get? Integrate x dx, what do you get? There's a table for that, including the trigonometry equation. Okay, go and download that table just to stand by. It will help you to solve problems. So this one, don't be scared by the trigonometry equation. Just see that as a normal y and x. Solve like what you solved just now. All right. So if you look at the structure of the question, actually basically it's the same like what you solved in the example 1, 2, 3, 4. Now we only change it to trigonometry, and this one is represent you solve the first integration. This one is the second integration. So what you do, you solve the middle first. You solve the middle equation first. And you write the middle equation, integrate 0 to pi, 2 plus sine 2 theta, and d theta. So again, there's a table to change 2 to something, sine 2 theta to something. So basically, you refer to table, you know. So you integrate 2, you get 2 theta and not x. This is theta, not x. So you just use back the theta. So 2 integrate the theta, you get 2 theta. Sine, again, sine, what do you do? Sine 2 theta, sine become cos with a negative sign. Okay, you integrate sine theta d theta, you get sine, you integrate sine 2 theta, you get minus cos 2 theta. And remember to go inside, to go inside the 2 sine theta here. Okay, 2 sine theta, you get 2, and you know that integration, you always divide with the n products. Okay, you always end up with the n products. For example, I flip back to the previous one. For example, this one, you integrate y dy, you always get y square divided by how many? Divided by the numbers exponential. Y square divided by 2. So divided by 2. Same principle here. You integrate sine, become negative cos. Go inside the 2 theta. You integrate 2. So you divide by 2 below. So that's why you get half there. Then follow to use 0 to pi. Okay. Now when you substitute the value here, especially you calculate cos and sine value, you need to convert the pi into degree, just for your calculation. Right? or some calculator, they straight away they can help you to calculate. All right. So you need to be careful on your calculator. So I do the first set for you. So the first set, you substitute pi into 2 pi become, 2 theta become 2 pi because you substitute pi inside there, and half cos 2 pi. Minus, you substitute 0, 2 theta substitute with 0, so 2 multiplied by 0, 0, and half copy, cos copy, 2 theta substitute with 0, you get 0. Again, apologize, there's no numbers outside the bracket because you already substitute inside already. There's no typo error here. Okay, now when you do this set, right, cos 2 pi, you know that 2 pi equal to 360 degree. 2 pi equal to 1 cycle, right? One circle is 360 degrees. So cos 360, you press calculator, cos 360 multiplied by half. 2 pi is 2 pi, right? 2 pi is in radian, right? And 1 pi is 3.142 something, right? So cos 0 is 1, right? So at the end, you arrive at 2 pi. Okay, that's 2 pi. In exam, you can give me a decimal place, no problem, but maximum 3 decimal place. Okay, but it's good that if you are giving the pi, use back the pi value. Next, you already solve for the middle one, expand to outside. Copy again the question. Right, integrate, then function, then the theta, the r. You already solved the middle one already. Substitute left-hand side answer, 2 pi inside here. This one replaced with 2 pi. So you integrate 2 pi dr. Okay, Shakir, what do you get? You integrate 2 pi over dr. What do you get?
Sorry, sir?
What is the next answer? You integrate 2 pi dr. What do you get?
2 pi x.
You integrate with what? Dr, right? There's no x,
Oh,
right?
2 pi r. 2 pi r.
The answer is 2 pi r. Okay. 2 pi r. Then after that, you substitute value with 1 and 4. Okay. Yeah. Okay, Shakir, you keep picking up already, right? Keep picking up, which is good, right? Then you substitute. I let you do the homework. You substitute. You'll get 18.85. This is how you do double integration, right? We look at one practical answer, practical question. Okay, look at example number 6. Area A outside the circle, radius, the area A outside the circle of radius, you have a circle with the radius r equal to c, and inside the circle, the radius r equal to 2c cos alpha is given by a double integral. Means you calculate the area using this equation. Basically, this is a double integral equation. Area equal to 2 integrate 0 to something, integrate c to something, r dr d theta. So it means that you do the same steps as what you learned in example 1, 2, 3, 4, 5. You apply the concept in this question. Show that the area equal to this one. So if the question asks you to show, you need to arrive at the final answer of this one. So we do like a normal procedure. You treat it as a double integral question. So you just copy the question and you do the middle first. You do the middle, integrate c 2c cos theta r dr. Okay, Edmund, what is the next step? So when you integrate r dr, what do you get?
R square over
R square over
2.
2, correct. You get r square over 2, and then you substitute below, there's a typo error in my slides again. It's not 0, but it's a c, it's a c. So you integrate 2c cos theta to c. You substitute inside there, you get a lengthy equation, right? Because the first part minus the second part. First part you substitute with 2c cos theta. Second part you substitute with c. You get a long equation. But you know that you can simplify this equation, right? You can simplify this equation, right? And before you simplify, if there's a bracket, remember there's a square in the bracket here. Please do your expansion first before you simplify. Yeah? So here, 2c cos theta square. So when you do square operation, 2 becomes 4, c becomes c square, cos theta becomes cos square theta. The rest the same. After that, you compare side by side. Are you able to factor? The answer is yes. You factor 3 square over 2, pull to outside. You'll get c square over 2, 4 cos square theta minus 1. You solve already the middle part already. Then you use this one, substitute back to solve outside one. Integrate 0 to pi over 3 and d theta, because you already solved up to here already. You already solved here to here. Substitute the yellow box inside here. Okay, we already get this one already just now. So substitute this one inside the bracket or inside the location here. Okay. So here, when you integrate over theta, you look into the question. C square over 2. C square over 2 basically doesn't link up with theta. What you do, c square over 2 is a constant value, and it do not contain theta. What I do, I pull the c square over 2 outside. I pull this one, this component in the bracket. I pull this one outside the integration and put them together with 2, so that I don't need to worry about c square divided by 2. When I pull outside, I can cancel the 2, right, outside the integral. There's a 2 outside integral. So when I pull, in fact, I can cancel right away. All right. Basically, there's a table 1339.1 to because why you need to refer to table 39.1, because the question gives you instruction to prove this one, to prove this integration into this form, into 2 pi plus 3 square root of 3. So how do you get cos square into 2 pi plus 3 square root of 3? There's no relationship, or there's no, not relationship, there's no direct conversion. You need a table to do conversion, right? Of course, if you have a good memory, no problem, but there is a tools for you to refer. So what does this table 339.1? Okay, you'll get this conversion. You convert this one to this one. You convert this one to this one. So why do you need this table? Because you need to convert, you need to simplify the cos square into something that only have sine or cos or tan. Don't have square one. You need to simplify the square component into something more simpler. I'll show you the table. This is the table 13.1. It's inside your handouts, inside the tutorial question that will help you to solve some question in the coming test and also your final exam. This is what you get just now. 2 integrate c square 2, basically you can cancel 2 with 2 already. You can cancel. So you only see c square bracket 4 cos square theta minus 1 with the theta. So you look at this table, you go shopping again. Okay, you go shopping. On the left hand side, you start with number 1, compare side by side. It is the same. The first one is cos square x. So this one, cos square theta, same. Because the rest is sine x, tan x, cot something, and then sine cos, and something, 1 over something. It doesn't related to this one. This one related to the first one, A. So what you do? You convert this one. Okay. You convert this one. Okay. You convert this one into this one. Okay. You get cos square theta in the first column there, first row. When you integrate your fx, you'll get half x plus sine 2x divided by 2 plus a constant value. All right. Okay. So you chain this one to following the first one. Huh? You change the x in this table, the first row, the x into theta. So what you get? You get half x, half bracket something plus c. So don't worry about the c because you have the limit here. So don't worry about the c. You just transform the bracket information into your answer. Half bracket x. What is your x? Refer to the information where you get your x. Cos square x. Cos square x. Your x is theta. Replace your x with theta. So that's why you get x. You get theta here. Change sin 2, then rewrite sin 2x divided by 2. Copy. Sin 2x, but your x now is theta. Remember, change the theta, change the x in the table into theta. That's why here you see sine 2 theta divided by 2. Just copy and modify a little bit. Okay, yeah? So in the test or final exam, don't direct copy the table give you x, you also write x here. No, huh? You need to refer to table 1, compare side by side. Know what is your x first. Cos square x. This is cos square theta. Change the x in the table, become theta. That's why you arrive at this one. Okay. Now, then you solve for first one already. Minus 1, you get theta lah. If you integrate with theta. So basically you can break this one. If you're not sure, what you do is that you cancel this one, multiply C2 inside here, multiply C2 inside there. You do 2 integration. You break into 2 operations. You do step by steps. Then you combine back the equation. Okay, this one is a bit fast. Means that I chain this one using table, this component, this one. Okay, I pull my 4 outside already. Okay, I pull my 4 outside. That's why my 4 is outside the bracket. And I do cos square theta using the table, integrate using the table. I get this one. And I integrate minus 1. Again, integrate minus 1 is the constant value. I get back the theta. Okay, that's why theta here. And there's a limit from 1 to pi over 3. This one you can do, right? Just substitute and then rearrange the equation. Okay, so this one I explained already. So from here, it become here, means I substitute, I do a big bracket, right? I substitute the first bracket with pi 3. So meaning the first bracket, 4 half I copy. This one become pi divided by 3. Sine 2 multiplied by pi over 3 divided by 2. Okay. Minus pi over 3. This is the first set. Again, when you do substitution, don't miss out anything in the bracket here. Then the second set, you know, is 0. So this one minus 0. So if you substitute 0 inside, you get 0. So this one 0. This one 0. So 0 plus sine 0. Sine 0 is 0. So 0 plus 0. So 0 multiplied by number, you still get 0. Minus 0, you still get 0. That's why you get 0 here. Okay. Rearrange, you need to rearrange your equation. You need to rearrange your equation. Press a calculator to find what is this value. Rearrange, you get c square bracket pi 3 plus square root 3 divided by 2, and the question asks you to arrange in this form. The question asks you to prove, so you need to rearrange back from this one into here. You factor the denominator. Denominator, you factor, and then not factor, but you change them. 3 becomes 6. 3 denominator below that, 3 becomes 6. 2 becomes 6. Okay, then you can combine them together, become 2 pi plus 3 square root of 3 for the top one. You push the 6 outside, you get c square over 6, and you rearrange, you get this one. So this is how you do double integration and how to do a proving kind of question. Okay, we stop here, stop my recording.